we are going to learn about shortest distance between two lines, both vector form and Cartesian form. So let us check how to apply the formula for shortest distance between the two lines. Okay, so you are having your two lines which are like shortest distance between the lines r vector is equal to I plus 2j plus k plus lambda times I minus j plus k, and r vector is equal to 2i minus j minus k plus mu times 2i plus j plus 2k. So you very well know that this equation is of the form of your first equation, like r vector is equal to a1 plus lambda v1, and the second equation is of the form of r vector is equal to, this is your a2 plus mu b2, right? So the formula for shortest distance between these two kind of lines is b1 cross b2. Okay, the parallel vector b1 cross b2 dot a2 minus a1 upon b1 cross b2 whole mod, and since we are talking about the distance, so we will put mod as we will consider only the magnitude, right? So now clearly from the first equation, how to choose who are a1 and who is b1. So this is my first vector, as it is of the form a1 plus lambda v1. So this is my vector a1 I plus 2j plus k, right? And b1 is your I minus j plus k. And in this second equation, your a2 is this vector 2i minus j minus k, and your b2 is 2i plus j plus 2k. So we will find accordingly your b1 cross b2, and then a2 minus a1. We will take the dot product of these and then divide this dot product by b1 cross b2 magnitude, and in this way we can calculate shortest distance between two lines using vector form. So let us check out a problem and let's solve it. So question number 14 of your exercise is find the shortest distance between the lines r vector is equal to I plus 2j plus k plus lambda times I minus j plus k, and r vector is equal to 2i minus j minus k plus mu times 2i plus j plus 2k. Okay, so firstly, how to start it? We will consider your r vector, means let us compare. It is of form r vector is equal to a1 plus lambda v1, the first equation, and the second one is r is equal to a2 plus mu b2. Okay, so let us understand what is your a1. a1 is your this first vector, so it is I plus 2j plus k, and a2 vector is your this one 2i minus j minus k. Okay, b1 vector is your this I minus j plus k, and b2 vector is your 2i plus j plus 2k. Okay, now we are required to find, let us see what is our formula for shortest distance. This is your b1 cross b2 dot a2 minus a1 whole divided by b1 cross b2 whole mod, and this complete also comes inside the mod so that we can consider the magnitude only. Now I will find first your b1 cross b2 and a2 minus a1. So let us check out a2 minus a1. So a2 minus a1 is 2i minus I is I, minus j minus 2j is minus 3j, and this is minus k is 2k, right? What is b1 cross b2? For it we will compute the determinant ijk. This is your b1 is your 1 minus 1 1, and b2 is 2 1 2. Okay, so this is I, this is minus 2 minus 1 minus j, this is 2 minus 2, and plus k, this is 1 plus 2. So this becomes minus 3i, this is 0j plus 3k. So we get it as your minus 3i plus 3k. Now let us find the magnitude also, as we need the magnitude also. So it is your under root of these components x square plus y square plus z square. So it is minus 3 square, as it is 0 plus 3 square. So it is your 9 plus 9, that is root 18. So it is 3 root 2. Okay. Now let us apply the formula for this, as we can calculate or directly put it in the formula also. So we are having your b1 cross b2. This is minus 3i plus 3k. This is 3k. Okay. So be careful, as we are having 0j. So there is no mixing or something while taking the dot product. We should consider that we are don't having j. Okay. We don't have any j. So dot e2 minus e1 is your I minus 3j minus 2k upon 3 root 2. So this is your, in the numerator, this is minus 3, this is your 0. So it's talking about it. So it's better you write 0j here, so that there is no calculation problem, and minus 6 upon 3 root 2. So this is your minus 9 upon 3 root 2. So this is 3 3s are 9. So this is, as we will take it out of the under root, so it is 3 root 2 units, or we can rationalize it also. So it becomes 3 root 2 by 2 units, which is the required shortest distance between these two lines. Let us take another example, which is your find the shortest distance between the lines whose vector equations are r vector is equal to 1 minus t times I plus t minus 2 times j plus 3 minus 2t times k, and r vector is equal to s plus 1 times I plus 2s minus 1 times j and minus 2s plus 1 times k. Okay. Now see, these equations are not properly expressed in the form of your r vector is equal to a1 plus your, here the scalar here is t, so t times b1. We need to express it in this form, and this one as a2 plus s times b2. Okay. So we need to separate. So let us write it in standard form. So it becomes, so without t, all will frame your a1 vector. So it is like I minus 2j plus 3k plus t times. It better you consider t as positive and then adjust it with sign with ijk. So it is minus I. This becomes, we will take the t. Okay. So it is plus j. This is minus 2t k. Okay. So t we have taken out. So it is 2k. Okay. And r vector is equal to I, this is minus j minus k plus s times, this is I plus your 2j, and this is, it will be minus 2sk. So s is outside, so it is minus 2. Okay, from the second equation. So we get these two equations here. Now you can very clearly check out what is a1 here, what is a2 here. Okay, so let us check out what is a1. So a1 here is I minus 2j plus 3k. a2 here is your I minus j minus k. Okay, so a2 minus a1 is 0I minus j plus 2j is plus j minus k, and this is minus 4k. Now let us check out what is b1. b1 here is minus I plus j minus 2k, and b2 is I plus 2j minus 2k. Okay, so b1 cross b2 is I j k minus 1 1 minus 2 1 2 minus 2 minus 2, this is plus 4 minus j, this is 2 plus k times minus 2 minus 1. So this is 2i minus 4j minus 3k. b1 cross b2. This is 4 plus 16 plus 9. So this is 20. This is 29, root 29. Okay. Now let us check out the formula. And the formula here is D is your b1 cross b2 dot a2 minus a1 upon b1 cross b2 whole mod. So this is your b1 cross b2 is 2i minus 4j minus 3k dot, this is 0. It's better to put a 0i instead of making a mistake, and this is your root 29. So this is your 0 minus 4 and plus 12 upon root 29. Okay, and the answer here is 8 upon root 29 units. Now let us check how to apply Cartesian method to find the shortest distance between the lines. So you are very familiar with the form of equations like x minus x1 upon a1 equal to y minus y1 upon b1 equal to z minus z1 upon c1, and x minus x2 upon your a2 is equal to y minus y by 2 upon b2 and z minus z2 upon c2. Right? So formula will be, you have to divide the determinant x2 minus x1. You can very well check from here what are x1 y1 z1 and e1 b1 c1, x2 y2 z2 and a2 b2 c2. So x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2. This determinant by your under root of a1 b2 minus a2 b1 whole square plus b1 c2 minus b2 c1 whole square plus c1 a2 minus c2 a1 whole square. So let us check out how to apply this formula. So question number 15 is there, find the shortest distance between the lines. So this is your Cartesian form, right? Now here, if it is not asked that you should go for Cartesian form, using vector form is quite convenient, but you should know how to apply this Cartesian formula also. So let us check out the formula for Cartesian form, that is determinant x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2. This determinant is to be divided by this big under root, and this complete thing will be inside the root. Okay, so complete thing will be, this is your determinant, and this, as we know that we have to take the shortest distance, and this is your a1 b2 minus a2 b1 whole square plus b1 c2 minus b2 c1 whole square plus a1 c2 minus a2 c1 whole square, and this has to come inside a big determinant. Okay, because we just need to consider the magnitude. So let us check out, compare the equation with x minus x1 upon a1, because this is the form. Compare with x minus x1 upon a1 equal to y minus y1 upon b1 equal to z minus z1 upon c1, and x minus x2 upon a2 is equal to y minus y2 upon b2 to z minus z2 upon c2. So we can check what is x1, y1 and z1. Okay, so these points are, let us check from here. You should check that what are your x1, y1, z1 here. So x1 here is, as we have to compare with this is minus 1. Okay, this is minus 1 and this is minus 1. Okay, x2, y2, z2, this is your 3. Okay, because it is x minus x2, so this is 3, 5 and 7. Okay, then what is direction ratios? a1 b1 c1, a2 b2 c2. So this is your 7 minus 6 1, 1 minus 2 1. Okay, so let us check out the determinant. So determinant is your x2 minus x1. Okay, so let us put it directly. x2, as the formula is written here, x2 minus x1. So this is, okay, 4. This is 5 plus 1, that is 6. 7 plus 1 is 8. Okay, then a1 b1 c1 is 7 minus 6 1, 1 minus 2 1. this is minus 6 plus 2 minus 6, 7 minus 1 plus 8 minus 14 plus 6. So it becomes your 4 into minus 4 minus 6 into 6 plus 8 into minus 8. So this is minus 16 minus 36 minus 64. So this is your 116. Okay, becomes minus 116. Okay, now let us check out what is E1 B2. Okay, let us put it in this formula. So E1 B2, E1 B2. So this is minus 14 minus A2 B1, A2 B1 plus 6, this whole square plus B1 C2, B1 C2. So it is minus 6 minus B2 C1, B2 C1. So this is plus 2. This whole square plus E1 C2, E1 C2. So this is 7 minus A2 C1. Okay. So this is A2 C1. So this is minus 1. This whole square. So this is your 8 square plus minus 4 square plus 6 square. This is equal to 64 plus 16 plus 36. So it becomes your under root 116. So let us check out what is the formula is. So the formula is going to be your, this is your D is equal to minus 116 divided by root 116. Okay, and just we need to consider the magnitude only. So it will be your 116 upon root 116. You can rationalize it. This is 116 root 116. So this is your root 116, which you can write it as 2 root 29 units. Okay, so this is how we can apply the shortest distance formula using Cartesian method.